So we're looking at finding the greatest common factor of monomials, in this case the simplest monomials where it's just a constant and then a variable to a certain power. So our first step is to write out each of these monomials into primes. And so we do a prime factorization for each one. If we take 25m to the fourth, we write the factors of the constant first, so this would be 5 times 5. And then we'll go off to the side just a little bit, so we'll leave room for other factors in case there are some. So we'll leave a little bit of a gap here, and then m to the fourth is just going to be m times m times m times m. Now we'll do the same thing for the second term, or the second monomial, 35m cubed. We always start with the smallest factor first. In this case, we'll have a 5 times 7. There's no other 5, but there is a 7. And then m cubed will be m times m times m. And then 20m squared. So that's a 4 times 5. Then m squared is times m times m. So then we look for common factors in all three of the terms we were given, and we have one column here of 5s, so it has, each of them has a common factor of 5. That's the only constant that is a common factor, or only one of the coefficients, factors of the coefficients that's a common factor. And then we have 2 columns of m that are in all three of the terms. So if we're looking at the greatest common factor, it's going to be 5 times m times m, which equals 5m squared. So the greatest common factor of 25m to the fourth, 35m cubed, and 20m squared is 5m squared. And essentially what we did, we just looked for the greatest common factor of all of the coefficients, and then we looked for the greatest common factor of the variable terms, where basically it's just the lowest exponent. When we're just looking at one variable, the greatest common factor of that portion is going to be the smallest exponent, which in this case was squared.